So, interesting enough, Google just gave me 15 health review comments 9 months ago. 9 months ago. What's going on here? Okay, I accept you and I are going to explore failures on this Pops. Whatever this AA is, whatever video that was, don't recall. I like your channel's name. It fits your content perfectly. You analyze construction engineering fundamentals too. No need to change it just because YouTube changed their rigorous algorithms. Right. Okay, so that's that one. This is weird. It's coming up like this. Let's click it and see where it goes. Over to the comment section, I believe. Yeah. So that was, it's over here then. So then going back here, let's just click this. Engineering for okay, let's do that. Wow, it's all coming in now. 1 year ago. More content. Email Griffin there. Explored structures on this. Gabriel Griffin. I'll come back to that for a second. I enjoy your channel. I often discuss your topics with my colleagues at the University of Texas Applied Research Lab. I've been following FIU collapse and I've yet to figure out how shims were added to the diaphragm. Did the structure get lifted to add the shims? The structure, well, I think I know what shims you're talking about. Hold on, type second. I recall from the NTSB report exhibit that shims were to be added immediately following the cracks. Can you comment? Wow, I'm sorry about this 9 years ago to my man here with the University of Texas Applied Research Labs. Those shims were to be added. There are shims already there, but it was theorized that in the middle the shims would be added. Let me see if I can still pop this up. The middle of the structure was to get shims to restrict the bridge's movement by I'm just trying to think I'm trying to think for anybody else too, not just you. So to restrict the bridge's movement. If we recall, so FIU bridge collapse. Let me see if I can get an image up real quick. Let me see if I can do that for us. And it was here. Okay, this will work. So if we recall, let's see if I can get that one up. The inside of this, they had cracks here and cracks here. The theory was to get shims underneath the center of this, and they did add shims, as I understand. They got some shims out there, so it couldn't move anymore. Thinking that if you stop it from rotating here on the diaphragm, that would also stop the bridge from rotating also, you know. Well, it kind of makes sense though. If this would have never moved at all, if you can just say, I can just grab a big hand and hold this from rotating, well, that confines everything else. And so that was, I think, the theoretical reason to put additional shims underneath the number 11, as I recall. Let's see if we got a better shot underneath. Yeah, look at that. That's nice. Underneath of there. Okay, report. Let's see if we can just, let's see if I can get you a, yeah, get you image. I think they might have a couple images in here. Let's race to the bottom here. And 9 months later, they give me your question. Okay, so, you know, wow, it's terrible. But let's see if we can still get that question worked a little bit. So that's the main span, back span is the other one. Where are you? So the shims were going underneath of here, center line. Not towards the end, as I recall. Let's see if we can get better images, and I'll rotate once we get them. That was that lateral bracing they had. I did a bunch of videos on that. Well, I did videos on that. Okay, this is without the diaphragm. This is just the deck image. This is with the diaphragm here. So the shims were going to go, well, the shims did go onto here. I think, as I recall, that I saw they had shims laid out there. These heavy-duty shims were laid out there. Now, remember the profile of this. I'm starting to get flashbacks now, recalling D1, D1, 2, 3, etc. Balancing each other theoretically, but they weren't balanced. D1 only had 400 and it had a live end and a dead end of the kips that were applied. So it was never in balance. It was off by, well, live end on this 471 kips, and on the other end it had clamp force greater. And I don't know where that clamp force resolved. In the middle of the single cable, it's a single cable line, right? So one end had more force on it applied on one end, more stress on one end of the cable, an amount of 18,000 pounds, 18 kips of force. And that's D1. Recall D1s are here. And then they balance out at 745 on one end. And this is not one end. This is the entire one end. The other end's the other one. And this is the, yeah, this is the live end. This was the live end, right? Trying to remember. This was the live end, right? Yeah, so this is the one with the at least the lower amount of kips compared to the other end. It's the one where they put the tooling down this end to apply it, to make the clamp force pulling it. And when they released it and it slacked, it dropped. You know, over here it dropped, what, 30 kips on all of these guys down here compared to the other end with a greater clamp force. The length was the same on all of the cables. And this bundle was the smallest, yet it was the closest in that radiant. I consider it like a radiant of forces going outwards. Let's go. Let's move it. So, shims. Let's see if we have any shims. This is interesting too. The timeline of when they applied the stresses. And let me get rid of that. I'm sorry, you didn't see what I just got rid of. A bug going across the computer screen. And I'm talking to you guys like you could see the bug. Okay. So let's see if they got the shim pictures here. All right, remember, cracks. All cracks have a reason why they're formed. Whether it's expansion, contraction, surface cracks, whatever you may have, but they all have a reason. Recall, we found a lot more real images coming up, not this limited batch of images here. And you can get a hold of my first videos where I said, oh, the deck is failing, deck is creeping down. Not the canopy, the deck. And because you get separation there. All right, down here again, they're the shims, shimmy shims. Shims will go down underneath there again. Shims are already placed. That was the level it, give it the pitch it required when I say level. Don't really mean level, the level to install it. And the shims were required with a certain amount of pitch per the plans to have water run off. And images here, we went over these images a million times and what came about that. And where are you? Right here. This appears to be their shims right there. Appears to be. I could be wrong. It could be a box of cardboard paper, as far as you know. But I think that's their shims right there. And the crack, the 45s. I did a little model of this, as you guys recall. I still got that model on my front porch. I kick it around every now and then, thinking I'd come back to this, and I was going to leave it alone pretty much. Here, your shims here, I believe. You know, the shims they used. The other shim was a different product. I talked about this crack. I'm getting more flashbacks now. This shows that the number 12 is lifting up. There's the gap here. It shows it's tighter here and wider down here, so it's lifting up and inwards. And that's not what, they did not talk about this in the OSHA report, exactly what's going on here. nor did they talk about it in the, my favorite people, my NTSB report. Fucking clowns. Um, they lack, they're government workers. What do you expect? And they used Fairbanks. It's crazy. It was, it's crazy how that came about. That they couldn't just read the data. They couldn't figure that out. That they cannot. And it's not crazy. I understand that it's not the easiest thing. But I see the corruption in it. And now we all see the corruption in government with what we're being put through right now. You remember that? That shows the twisting action of the structure. Up, lifting up, creeping down, lifting up, and twisting. I mean, come on. So what do we bring back in here? Look at that huge rotation there. Huge rotation. Did they talk about this rotation? No, they didn't. But yeah, it's clearly a rotation going on here. And I said no, they didn't. Let's command find and look up rotation. So in this report, I look up the word rotation. How about rotate? I find rotate one time. This is when they were placing it, but they don't talk about the rotation in the images that you see there, that there's rotation going on. Sorry, guys, it's you gotta be a nut job like myself and put your brain and be able to triangulate and put all this stuff together and fight your own brain about any conflicts that you may have and say, wait a minute, but I need you to resolve this. And that's the way I process. I may come up with something, but then later I may say, but, this is still unanswered. Can it fit into your formula? Or whatever you stated. And if it cannot, I got to do a retraction. Yeah, I believe this is the live end where they pull from. So this has the least amount of kips on the structure than the other. Nevertheless, I think this is, again, just longitudinal post-tension failure. The deck, it flexed in the middle and kept on going. Oh, it flexed between it failed down towards between 9 and 12 is where it started going. The breaking of the back, the strong back, the canopy did not participate as much because they had a weird ass profile in the canopy that wasn't really designed to act as a strong back. It was designed to hold the concrete from flapping over more. So at least if you look at it, that flat, my opinion on the rotate on that. On the oh great, I got to get rid of the word rotate. It keeps doing that, resetting. For the umbrella, the canopy action. Yeah, beautiful 45s. I mean, both sides of that. I was talking about the gap here, that this measurement is higher than the other one. It proves the rotation. That this was like 5 inches, and the other one was like 4 inches. This is like 1, 2, 3, 4, 5 inches. And then the one to the right, I'm having a little fun now because I'm COVID bored. And this one's like 3 inches, even though he put it in the wrong, he put this one over here on an angle and read clearly, and it's not near number D1. And then this one, he put directly on the D1, so it shows he engineered it. Come on, how hard would it have been to done this? How hard it would have been to do the same on the D1. Okay, I don't know what tooling they use to pull the cables on that. And fast forward. All right, so there's your shim. Oh, that's right, shims. I showed you the shims. So the shims were going to go underneath of there in theory, so it couldn't bend. Part of me thinks he knows that Denny Pate knew what was going on, and then part of me thinks he didn't know what was going on and didn't think much of it. and put the clamp on the shims to do that restriction down the bottom of 12, and they ran with that. So you know, and all this hindsight and thinking about it, you know, if you want to, you know, if they've already their pound of flesh as Denny Plate did it, and you know, bad engineering, right? Denny Pate's position is that Denny Pate and the engineers is position that it's bad construction by Manila Group, whatever the hell they are, whatever they changed their name to. Well, and I'm in a position that the video and all the data said that, well, if the post-tensioning cables in the deck never elongated, then we wouldn't be looking at a failure. So think about it. If they never elongate, they would never be looking at a failure. Part of my videos talking about COVID, I said, COVID has killed no healthy person. I'll be a winner of that statement no matter what. It kills a healthy person, I said, well, then they weren't healthy. So it's sort of that way that I'm saying about the cables, is that if the cables never elongated, we get no failure. So the deck, we know the concrete will fail, right? If you just did that without the cables, the amount of steel in there, and the thickness, the ratio of the thickness here, right? It's just going to fail. So the cables were designed to keep it in that compression, so it never goes into the tension on the bottom of it, never opens up. So and so if the cables could never open up, then, or you know, the cables could never elongate, then we can't get the opening with the tension of the weight of the deck, putting tension on the bottom, opening up the bottom of this deck and causing it to go towards the ground. Could never have happened if we didn't get elongation inside the cables. Period. It just could not happen. They, on the other hand, have somehow magically stating that this is a truss system, and that during this truss system, the number 12 and number 11 interacted and failed, and caused the deck to it caused everything to fail. I went over that with you in other videos, saying that no, 12 can't make itself longer. It's attached to the canopy, and when you see the failure, it doesn't magically the system doesn't flex. It's concrete. It's not going to do all that what they're describing. And plus, we look at them releasing it when they release tension on number 11. We got this huge rotation going on, which 11 was supposed to be in compression, and then they turn around and put more compression back into it. Make up your mind. You just said it was sliding and pushing 12 off the deck. That puts it in compression. If it's pushing 12 off, it puts it in compression. So why are you putting it into compression again with post tensioning? You see, that doesn't make sense to me. All right, so end of video, and that's for my man there from 9 months ago. Hopefully you can appreciate that. I'll put you in the comments or in a video response. Hopefully still around. Wish you well at that. It's your colleagues at work there. Bye.